Have you ever just stared at a big, messy set of equations and had no idea where to even start? Well, today we're going to break down an incredibly powerful method that can solve even the most tangled systems, one clean step at a time. Let's dive in.
So take a look at this thing. 3 equations, 3 different variables, it's a total tangled web, right? Now, your first instinct might be to just start substituting one variable into another equation and just, hope for the best. But that can get super messy really fast. But what if I told you there's a much better way? A method that takes all this chaos and systematically turns it into a simple, elegant staircase that you can just walk right down to find the solution. It's called Gaussian elimination.
And the genius behind it? None other than Carl Friedrich Gauss, one of the most brilliant minds in the history of mathematics. He gave us this incredible tool for taking what looks like an impossible problem and turning it into something we can solve, step by step.
Okay, so the very first step is all about getting organized. We're going to clean this puzzle up. We're going to strip away all the variables, the x's and y's, and focus only on the numbers themselves.
And we do this with something called an augmented matrix. Seriously, don't let the name scare you. It's just a simple grid that holds all the important numbers, the coefficients on one side, the constants on the other, separated by that vertical line. All of a sudden, no more x's, y's, and z's cluttering things up. It's just a much cleaner way to look at the exact same problem.
All right, now that we have our puzzle board set up, we need to know the rules. You can think of this whole process like a strategy game. And in this game, there are only 3 legal moves you're allowed to make to get to the solution. That's it, just 3.
And here they are, the elementary row operations. You can swap 2 rows. You can multiply any row by a number, as long as it's not 0. Or you can add a multiple of one row to another row. Now, these might seem kind of random, but here's the secret. This is just basic algebra in disguise. Swapping 2 rows, that's just like writing your equations down in a different order. And the other 2 moves, that's the same thing as multiplying an equation by a number or adding 2 equations together. Stuff you've been doing for years. We're just doing it in a super organized way now.
Every good game needs a clear goal, right? A win condition. So what are we trying to do with these 3 moves? What does the finished puzzle actually look like? Our goal, our win condition, is to get the matrix into what's called row echelon form. Just look at that beautiful structure. You've got a diagonal of 1s with 0s tucked in neatly below them. It makes this perfect staircase shape. And that shape is the whole key, because once you have it, the system becomes incredibly easy to solve. Every single move we make is just a step to get us closer to this clean, simple form. Okay, theory time is over. We've got the setup, we know the rules, and we have our goal in sight. So let's actually put this all into practice. We'll start with a slightly simpler 2-variable system just to get the hang of the moves, and you'll see how this exact same logic works for the bigger, tougher puzzles too. So here's our system, 2x plus 3y equals 6, and x minus y equals 1/2. We've already put it into its augmented matrix. You can see the coefficients for x and y, and then the constant sitting on the other side of that line.
All right, first mission. Remember our target form? The very first thing we need is a 1 in that top left spot. Row 1, column 1. That's going to be our anchor for everything else.
So how do we get a 1 there? Well, we could multiply that first row by 1/2. But look, there's a much easier way. Row 2 already has a 1 in that spot. So let's just use our first legal move and swap row 1 and row 2. And boom, just like that. One move, goal number 1 is done.
Okay, next up, we need to start building that staircase of zeros. Our next target is that 2 in the second row. We've got to turn it into a 0.
So how do we do that? We're going to use that 1 we just made as a tool. If we multiply our new first row by -2 and then add it to the second row, that 2 turns into a 0. The other numbers in that row change, of course, but that's fine. That's part of the process. Goal number 2 achieved.
We are so close now. The very last step to get this thing into our target row echelon form is to change that 5 in the second row into a 1. We need a 1 on the diagonal. And this is a perfect job for our second legal move. We're just going to multiply that entire second row by 1/5. And there it is, a perfect staircase. We have 1s on the diagonal and a 0 below it. Our matrix is officially in row echelon form. We've won the game. Okay, but what does winning actually get us? What was the point of all that? Well, this is the best part. This is the payoff, turning our beautiful, clean matrix back into an actual solution.
Just watch how simple our original problem has become. Let's put the variables back in.
That first row is now x minus y equals 1/2, and the second row, it just tells us that y equals 1. The answer is literally spelling itself out for us.
And the rest is, well, it's incredibly easy. We know y is 1, so we just plug that value back into the first equation. This is called back substitution. So x minus 1 equals 1/2. A tiny bit of simple algebra, and we get that x is 3/2. The puzzle is solved.
And what's really powerful about this method is that it also tells you when there isn't a nice single answer. If you get to the end and have a row that says something like 0 equals 4, well, that's impossible. That's your sign that there's no solution. And if you get a row of all zeros, that's a sign that there are infinite solutions. The matrix always tells you the truth.
So, why does all this matter? I mean, this isn't just some neat math trick for a classroom. This is the hidden engine running behind so much of our modern world. It's used in computer graphics to create 3D images, in engineering to analyze complex circuits, and in finance to figure out how to balance huge investment portfolios. It's a fundamental tool for taking chaotic, jumbled up data and finding clear, actionable answers.
So I'll leave you with this thought. At its heart, this is a method for finding clarity in the middle of chaos. So what complex problem in your world right now could be simplified if you just found a way to tidy up the numbers? That's it for this time. See you on the next explainer.